Hello everyone. Welcome back to our tutorial video. This video is mainly made for my online class. Yes, that is the main reason why I produced this video. But of course, I believe also that this video might be helpful, especially for student in electronics or a student in engineering class, or maybe the students also in electronics in high school. I hope this video will be this tutorial video will be very useful to you. Now, if you find this video useful to you, do not forget to like and subscribe to my YouTube channel. Yes, this is the income. If I could have an income of this video, is for the cost of the additional materials or equipment for my charitable school. Yes, I'll be donating it towards the expenses on the components and other materials for the students. Okay, anyway, in this video we will be discussing about diodes. Yes, and what are the things that you may learn if you watch this video until the very end. Then these are the following that you may learn. The first one is you will learn on what is diode. Yes, and then you will also learn on how does the diode blocks the current in reverse direction and allow the currents to flow in forward direction. So you will also learn that. At the same time, you will also learn on the different basic, just the common types of diodes, of course, with their corresponding function application, yes, in the circuit. You will also learn in this video on how to test diode with the use of analog multimeter. Yes, in this video we will be discussing in how to test diode with the use of the analog multimeter, because practically you can buy analog multimeter in low cost, that is cheaper than the digital multimeter. So I prefer to discuss how to test diode with the use of the analog multimeter. Now, if you have clarifications, you have questions, do not forget to write a comment below. Yeah, write a comment below for me to know what are those things that I need to improve. Yes, or what are those clarifications. So, what are those things that you need most, so that I can also uh, make something, can address it. For example, I can make a video out of it. Yes, tutorial video, the same as this. But anyway, so I guess let's proceed. So we have it here. The first thing that we'll be talking this morning is, in this video, the first thing that we'll be talking this video is what is a diode. Okay, so a diode is a semiconductor device with two terminals, typically allowing the current to flow in one direction. So this is actually the one of the main function of a diode in the circuit. They are commonly used in the circuit because of their ability to allow the current to flow in one direction. In the other direction, it will block the flow of current. So that direction that diode will allow the current to flow is, we call it as a forward bias. Yes, and when the diode is connected in reverse bias, then it will block, or it will not allow the current to flow. Now, in this definition, diode is a semiconductor device. So we talk about semiconductor. We have here below. Semiconductors are materials which have a conductivity between, or that is the properties in between conductors, and those conductors are generally metals. Yes, conductive materials are usually made up of metals. Then in non-conductors, we talk about non-conductors. Those materials can be plastic or ceramic or any other materials that will not allow the current to flow. We call it as an insulator. Yes, semiconductor can be pure elements such as silicon and germanium. So usually we talk about semiconductors, they are made out from the silicon materials or germanium materials. Okay, so I hope that is clear. So again, just to make it clear, semiconductors or semiconductor material are a material which has a properties that sometimes it will act as a conductor, and sometimes also it will act as insulator. So it will act as a conductor when it is connected in forward bias in the circuit. Yes. And when it is connected in reverse bias, when it is in reverse bias in the circuit, then it will act as insulator. So insulator again, insulator is a characteristic that these are materials that has a very high resistance that will not allow the current to flow. While conductor, those are materials that has a very low resistance that is allowing the electrons to travel, that is to conduct current. So current can flow on the conductors while current could not flow on the insulators. So again, characteristic of semiconductors, it sometimes act as a conductor, a conductive material, and there are times also that it will act as an insulator material. I hope that is clear. The next is diode is made from combination of two extrinsic semiconductors. Yes, it is made up of the combination of two extrinsic semiconductors, the p-type and the n-type, or we call this also as a p region and n region, or the positive part and the negative part materials. Okay, the joint between the p and the n-type materials is called p-in junction. So it means the in between these two type, the for example, on the other side is the p type, and the other side also is the n type. This part in which they are joined, that is, we call it as a p and n junction. Okay, so basically a diode has two terminals. Yes, it has two terminals. One is the anode and the other one is the cathode. So anode is actually a terminal or a part of a diode, a side of a diode that is considered a positive, or that is the p type or the p region. So anode is for positive terminal and the cathode is for the negative terminal. So if you are connecting this diode towards the circuit, it should be that the anode is on positive and the cathode is supplied with negative, or it should be in the negative part of your circuit for your diode to be connected in forward bias direction. That's it. Okay? And then diode is produced from the silicon wafer or germanium wafer. So again, as what I said, diode can be made up of silicon or made up of germanium materials. Do not be confused on that. In this video, we will just be making things into its simplest way so that you can understand this easily. Yes, you must understand this topic easily because that is what this video is made for you to understand the things clearly in a very easy way. Okay. Next is near or closer to the p junction, the electrons diffuse into the vacant holes in the p materials, causing the depletion region, or some call this one as depletion zone. Yes. When I talk about depletion region, this is the part of the diode that will block, or this is a part of the diode that will block the current of flow in reverse direction, that is in reverse bias. Yes, when your diode is connected in reverse bias, it will block the current of flow in it. That's why it is defined as diode will only allow a device, semiconductor device, that will only allow the current to flow in one direction, because when it is connected in reverse bias, it will be forming a depletion region, and this is responsible in blocking the flow of current in the other direction. Okay, this depletion zone or depletion region, do not be confused. Yes, acts like an insulator, preventing the other electrons in the p or the n type silicon and the holes in the p type silicon from combining. So it means when the diode is connected in reverse bias, there will be a formation of depletion region. Yes, and this depletion region will block the current to flow in the opposite direction. So for example, if you supplied negative current towards the anode, then that positive current from anode could not reach towards the cathode, because that is in reverse bias. But if you supplied negative current on the cathode, that negative current can pass towards the anode, since the negative current is supplied towards the cathode. Okay, so and there is another way to let the current block, or if you want to block the current to flow in the other direction, you must be able to learn on what is the function of the diode in your circuit, because actually this application of diode in the circuit in blocking the current to flow is very useful, especially if you are to create different principle on the logic gates. Anyway, those logic gates are the highest, shall I say, a little bit higher on the electronics. All you need to do is, if you want to learn those, yes, you have to go through the basic. These things that we are doing here is the basic, yes. Anyway, we will be talking about that as soon as we will be done with the rest of the task. Okay. Next is, what is again a diode? So in addition, this leaves a small electrical imbalance inside the crystal. Yes, so when your diode is connected in reverse bias, it will become an imbalance inside its crystal, its body. Since the end region is missing from electrons and it has obtained a positive charge, so when it is the negative side is connected towards the positive, what will happen is the negative region will be missing some of the electrons, yes, and it will obtain positive charge, and the extra electron that fills the holes will go to the p region and will give it as a negative charge. So what will happen, unfortunately, one cannot generate, yes, one cannot generate power from electrical imbalance. So however, the stage is set to see how the pin junction functions as diode. So though that event will not allow the electrical imbalance to, or when you talk about when there is an electrical imbalance, this device will not allow the current to flow. So in that way, that is actually very useful to us to have, or to let the diode work its function to allow the current to flow only in one direction. That is one thing also that we must be proud of, because that is a very useful towards electronics characteristic. Okay, so how does, next one is here, how does depletion region work? So we have this. So this is by the way, this is our diode. For example, the red part in here is our positive part of a diode, and the color green is the negative part of our diode. And of course, the positive part, as what I'd mentioned a while ago, it is the anode, and the negative part is the cathode. Yes, and the symbol in here. So this is our example symbol. There is an arrowhead. Yes, and the tail of this arrowhead is, we consider this as the anode terminal of our diode. And on the tip of this arrowhead, there is a vertical line, and the line after that is what we call as the cathode, or negative of our diode. Now, in actual picture, in actual diode, so this is, for example, we have this picture, this a rectifier diode, yes. On its body itself, it is coated with either color white or a silver, or it might be a gray, yes. That part that has a coated, then that is, we consider it, or that is the part of a diode which is a cathode. So this part in here, these are the cathode. So it means that this is the negative leg or terminal of your diode. While the other side, the opposite side that has no coated part, this is what they call as the anode part of your diode. So in other picture in here, we have, this is our example of Zener diode. Now in Zener diode, there is a color black on its side. Now that part that has a black color, that is considered as the cathode, and the opposite side would be the anode. So it means this part in here is our negative terminal of this diode, and the other part would be the positive. Okay, so let's continue. How does depletion region work? How does depletion region blocks the flow of current? Now let's have in here, this is our illustration. So this is the p type, this is the n type. Once this is supplied with the positive, what will happen is this region in here will be having the positive charge. So these electrons coming from here will move towards the p region holes in here. yes, this negative ion from here will move in there, and then since you supplied positive in this part, yes, what will happen, this part in here also, this is supposed to be an electron position, this is the electron holes. What will happen, this will become positive in charge, and here will become the negative in charge. This two imbalance, it will become now imbalance, because supposed to be here should be negative and here should be positive. What will happen is the depletion region now is made, and this becomes the imbalance this diode, so it will become the imbalance, electrical imbalance. So what will happen, this part in here, this depletion region will block the current of flow from this part towards in here, or from here towards this part, because again there is an imbalance of the electricity inside. So there's an electrical imbalance inside, there's a charge imbalance of charges inside, and that way this diode now will act as insulator. It will not allow the current to flow. So that is one thing that you need to remember, that when the diode, I mean the deflection region is made, when your diode is connected in reverse bias, then it will not allow the current to flow in the other direction. So it will not. So again, the diode will not allow the current to flow in reverse direction. It will only allow the current to flow in forward direction. Okay, but do not be confused when I say forward. It is not referring only that the diode, I mean the current will only flow from positive to negative. But it could be also that the current can flow from negative towards the positive side of your diode, as long as the current that you supply in negative also, negative side is also a negative current. That what will reach also to your positive, or your anode terminal of your diode is also negative. That's something that is you need to remember, you need to understand that I talk about forward bias. It is not only always that we allow positive current to flow. It could be also that we allow negative current to flow towards the device. Okay, it is actually vice versa. Yes, it could be that the negative current can flow or the positive current can flow. It depends on the orientation of your diode. That's why it is very important for you to understand and what is the connection, either it is on forward bias or a reverse bias. Okay, I hope that is understood. So the next one here, so how does this depletion region work? At the p-n junction, the electrons from the n-type semiconductors will be attracted to the holes in the p-type semiconductor. So that is being illustrated a while ago. Yes. And as a result, the holes of the electrons in the p junction disappear. Yes. And perform a layer called depletion layer. That is the depletion region. So do not be confused. The depletion layer is referring to a depletion region. At the same time, the p-type semiconductor becomes more negative, whereas the p-n-type semiconductor becomes more positive. So again, if the diode is connected in reverse bias, so what will happen is the charge on the positive and negative will become opposite, because you are going to connect it in the other way. So that is why that is called as a reverse bias. And then in reverse bias, the deflation layer, the depletion region will be made. Okay, once they are created, they are capable of blocking the flow of current, because there is an electrical imbalance. There is an imbalance in its property, in which the positive should what I mean, yeah, the positive must have positive, but what happen is the positive becomes or supplied with negative, so there is an imbalance in its property, and that's creating, and that creates the depletion region, and that blocks the current to flow. Okay. Next part, so you try to look at, you try to read it. This will result into potential difference across the p-n junction. Yes, there will be a difference because its polarity is not followed. Yes, this potential difference is called the junction voltage or the barrier voltage. Yes, that voltage that we have, the positive in here. Yes, instead of negative, it becomes positive, and the other part becomes also the negative instead of having it a positive. So we call it as a barrier voltage. The junction voltage will prevent the charge carrier from flowing across the depletion region, and that is the way that this diode blocks the current flow in reverse direction. Okay, we have here. Next part is the types of diodes. So there are only, I just place here the very common diodes. Yes, we only need to talk in this video on the basic common diodes that we'll be working on our project. So the first one here, the first type is we have the power diode. Yes, a power diode might look like this or the other way around. So there are different types also of power diode. Their main function on the circuit is rectifying power supply circuit. Talk about rectifying, it is to increase. Yes, rectifying is to gain. Yes, gaining power. Where can you see those power diode? You can also see this one in the microwave oven. Yes, in microwave oven you are having there a power diode in which that diode will help a transformer to raise up the voltage level until 5,000 volts in order for your magnetron to be um, having enough power supply to create or to produce a microwave radiation that will cook food or reheat food and something like that. Yes, again, one of our diode type we have here, the power diode is again rectifying power supply or to increase. About rectifying is to increase, to rectify, to increase the amount value of the voltage. That is one of the function of the power diode. Next, we have the signal diode. Talk about signal diode. These are signal that will or they are used usually in the sensor of a radar. Or these diodes will send. Yes, they are used for making sending signals. They are usually used for radars. Yes, radars are usually used also for the cargo ship. Yes, transportation, just like to go and so on. Do not be confused, okay? Do not be confused. Again, if you have questions, doubts, clarification, please do not forget to write a comment below. Yes, do not forget. Next, we have in here the Zener diode. Zener diode is a voltage. This is called. This can be. It's one of its application is a voltage regulator in a power supply circuit. Yes, because it has its ability to once the supplied voltage is in its maximum or more than the limit, then it depends also on the type of zener that you have. It will create a constant voltage output after which. So it means this zener diode can be used also as a regulator and voltage clipper of a power supply circuit. So it means you are to either to increase or to adjust the voltage in your power supply. Of course, it depends on the application of your Zener diode, because once the voltage is not enough on once the voltage is not enough on the diode, because there's a specification. Yes, there's a specification on a Zener diode. We have this what they call as the reverse voltage, or the voltage that is enough for this diode to produce a constant output. Okay, so I hope that is understood. Next, we have here, and this is our LED, or the light emitting diode. The light emitting diode is usually used in the circuit as an indicator light. Yes, they are usually used as indicator light. Indicator is, for example, a power supply. They are placed, of course, this LED should be paired with or should be connected in series with a resistor to protect this from damaging, because this is more or less only has 1.8 volts. Yes, it needs only a very small amount of voltage as well as in its current. That's why you need to connect a resistor in its one of its leg. It could be in the positive or the negative, but the better way is on the negative side, or in the positive side, and it should be connected towards the positive. Again, the main purpose is to limit the flow of current. Yes, and main application of the LED is used as indicator light. Yes, indicator. For example, if in power supply, we use LED to indicate that your power supply is receiving a power source from the, or we use this also if to indicate if your power supply is on or off. It's one of its application. And so many other, depending on the design principle that you want to have in your circuit. Yes, that's it. Next, we have the channel diode. No, channel diode. These diodes are usually used for the oscillation, and we can usually have this in our oscilloscope. Usually, the oscilloscope circuit has this channel diode. The main purpose is the oscillation. Oscillation, it means to create a signal, whether to make it high and low. That's oscillation. It means the changing constant signal, that is oscillation, oscillating part. So like I say, a blinking of light is oscillating. The light now is turning on and off. It means the current that flows in there, it goes high and low, high and low, high and low. That is one example of the oscillation. So that is one of the, for example, if you have the LED flasher is one of the example of the oscillator circuit. It means it goes high and low. So yes, the output of this circuit becomes high and low at from time to time. So there is an oscillation. There's an interval of turning this output as high or low. Okay. Next, we have the varactor diode. This is also what they call as the variable capacitor in nature. Yes, in nature they are also a variable capacitor. But of course, they are used in that because sometimes they could again allow the current to flow, and sometimes they will allow the current to flow. There is varactor diode is usually used in a tuned circuit. Yes, they are usually used in a tuned circuit. Next part is we have here the photodiode. Now this photodiode is a light sensor. Usually we can see this one in the remote of our TV. Yes, the part that will receive the signal from our remote. That is what they call as, or that is an example of a photodiode. Yeah, I hope that is understood. And we also have here another type. We have laser diode. We talk about laser diode. This diode can are usually used on the DVD player to read the disc, compact disc. For example, they are the one to, once the discs are rotating, this plays on the reader of the disc. This will read on what is inside of the disc. So this is usually a laser diode. So do not be confused. Laser diode is not really referring to the laser light that we have. Yes, those toys. Toys that we have. The part in which we can project. We call it as LED light. We can point into a specific place and there is a light running through it. Yes, it's not referring to that. We talk about laser diode again. It is usually we can see this example on the DVD player that is responsible in reading what is inside of the compact disc. Yes, I hope that is understood. As what I said, if there are comments, there are clarification, do not forget to write below because I believe nobody's perfect. So please try to tell me if there is something that I need to improve. Next, we have here the last part, our last type of diode that we'll be talking today is a rectifier diode. Rectifier diode is actually a diode in which in the actual picture it would look like this. There are different specifications, yes, depending on the how many current, how many amperes do you want to have in your circuit, how many, what is the voltage value that you want to have. Yes, there are different specifications in this. The main purpose of the rectifier diode is to convert alternating current towards direct current. So again, this is one of the very useful in the electric, especially in making a power supply. That is to make alternating current towards direct current because electronic devices, electronic circuits are not, yes, they are not powered by alternating current. Instead, they are powered by direct current. And to produce direct current with the use of power supply, we really need rectifier diode or diodes. Of course, there are different types of rectifier circuit. Anyway, we can have it maybe in the next videos. Yes, but in here, we only have a rectifier diode. Again, its purpose is to convert alternating current towards direct current. It could be a small amount of AC current towards DC current. It could also be 200. For example, in the Philippines, yes, we have 250 volts. We can change it. Yes, but we need to use also higher bigger size in a rectifier diode because the voltage value is too high. Also, we can create. Yes, no problem with it. Okay, now this time, yes, we proceed to how to test diode. As one of our tasks for this morning in this video, how to test diode. Of course, to be specific, is how to test diode using analog multimeter. So as what I'd mentioned, it is in practical ways. It's better for you to learn how to use analog multimeter in testing diodes or testing any type of electronic components because besides from it is low in cost. Some also, especially if they are students. Yes, if they are student, if you are a student, yes, you will have this limited budget to buy for testing equipment, testing instruments. So that's why it's better for you to buy a cheaper one, especially if you lack budget. But of course, if you have lots of budget, you can buy directly digital. Anyway, but in this video, I'll be discussing on how to use analog multimeter in checking the condition of a diode, whether your diode in the circuit needs to be replaced or uh, your diode in the circuit is not the cause of the trouble. Okay. Step 1, there are steps. Yes, there are steps to follow in testing diodes. I'll just be giving very concrete things to follow just for you to make it by your own. So that is what you call as DIY, do it yourself. Yes, I want you to learn that. So the first one we have here, keep the multimeter selector switch on the low resistance value. So there is an ohm range, so you set your ohm range into a low resistance value. I suggest that if you want to test diode, you have to set your multimeter more or less most for me, that's for me, most accurate. You have to set it into times 10 as our range selector. I mean our range setting for the ohmmeter of our analog multimeter. So that's it. You need to do it. You need to set. The first thing is set it on to low resistance. That is times 10. Okay. Next is number 2 is connect the diode in forward bias. Condition by connecting the positive. Yes. Connect your diode in the forward bias. So how to connect your diode in forward bias is to connect the positive of your test probe towards the anode, and the negative test probe of your analog multimeter is to the cathode. Now remember this. Once you use analog multimeter into semiconductor materials, what will happen is the positive, the red test probe will become the negative. The black test probe will become positive. Why? Because the black test probe is the test probes are directly connected towards the battery inside of your multimeter, and the black test probe is directly connected towards the positive, while the red test probe is directly connected towards the negative of your battery inside. So that's why, as what I said, you have to bear in your mind that when you use analog multimeter for semiconductor materials, the black test probe becomes positive and the red test probe becomes negative. Okay? So, to connect your diode in forward direction, it should be that the red test probe should be connected towards cathode because, again, the red test probe becomes negative, yes. And the black test probe should be connected towards the anode, that is the forward bias, that is connecting your diode into forward bias. Okay? But anyway, next, we have here, we only have 4 steps to follow. So, number 3 is connect the positive test probe to the cathode and the negative test probe to the anode. In this case, you are connecting your diode into reverse bias. Okay. So again, the first step that we to follow is to set your multimeter into low resistance. And I suggest you set it into times 10. Yes. The second is connect your diode towards your multimeter in forward bias. The third is connect your diode into your multimeter in reverse bias. And the fourth one is the result of the connection in both forward bias. You have to observe. So the only thing is you need to remember the result of the connection in both forward and reverse bias, because that will lead you to conclude on what is the condition of your diode. Yes, that is our basis for the conclusion whether your diode is in good condition or not. Then That is the result of the testing in forward and also in bias. I mean reverse bias. Forward or reverse bias. You need to know the result of those connections. Okay? So I hope so. So we have in here. This is our illustration. So keep your multimeter selector switch on the low resistance. So we have in here this picture. It's as what I said. I suggest it to be connected towards the times 10. Yes, it should be connected into times 10. But before, of course, before you proceed to the next step, make sure that you set your needle pointer exactly on 0 ohm. So upon selecting this part in here in your selector, you intersect the two test probe as what you can see in this picture. You connect the two test probes. Yes, by connecting your two test probes, your needle pointer will move from this part in here towards the 0 ohm. And if your needle pointer does not stay exactly on 0, you turn this rotary knob, yes, the 0 ohm adjustment knob, this part in here, you turn this, it's either clockwise or counterclockwise direction, just to move your needle pointer exactly on 0 ohm here. So again, before testing diode, make sure to set your needle pointer exactly on 0 ohm. Okay, how to do that? Set first your range selector into times 10 as what I suggest, and intersect the two test probes. It means connect the two test probes or your multitester. That will cause the needle pointer to move from the infinity side towards the 0 ohm side. And if the needle pointer does not stay exactly on 0, then you use this 0 ohm adjustment now to move the needle pointer exactly on the 0 ohm. Okay, I hope that is clear. That is the first step that you need to follow in testing diodes. Next step, you have in here forward bias. So after setting, of course, you already set your needle pointer exactly in the 0 ohm. You have to connect now your test probes towards the diode in forward bias. How to do it? Very simple. This red test probe should be connected on the cathode, because as what I'd mentioned, what will happen to your analog, the red test probe will become negative if you use it on semiconductor materials, and the black test probe becomes the positive if you use it again on the semiconductor material. So again, we have here, this is the illustration of forward bias. The red test probe should be connected on the cathode, and the black test probe should be connected on the anode of your diode. Okay? Now, if the condition of your diode is good, during forward bias, it will give a reading of low but not zero. Something like this. Yes, it is low but not zero. Again, the reading of your multimeter should be low but not zero when your settings is like this, and the connection of your test probe towards your diode would look like this in here in this illustration. Okay? If this is the forward bias, the reading, when your diode is in good condition, the reading should be like this. But of course, we could not tell already that your diode is in good condition, but we need to consider first, but more or less, this is the reading for the forward bias, but more or less, we need to consider also the reading on the reverse bias. Okay, next one, we have here. This is now the formation of the reverse bias. The same thing, you need to set your needle pointer exactly, set your range selector into times 10, and then, of course, before testing, make sure that your needle pointer, you set it in the 0 ohm, and once you remove the two test probe, since you intersect and set needle pointer exactly on 0 ohm, once you remove it, your needle pointer will go back into its initial position, the infinity side. Okay? Upon connecting your test probes in here, the same in this illustration, the red test probe now will be connected to the anode, the black test probe now will be connected to the cathode. What will happen if your diode is in good condition, then your needle pointer will not move at all. It will just stay in the infinity side. So in this way, in that two results, so in the forward bias, just a while ago here, if in the forward bias you can get a reading of low but not zero, and in the reverse bias you can get a reading of infinite, it means the needle pointer does not move at all, then I can tell that the condition of your diode is good. That's it. So why? Because diode will only allow the current to flow in forward direction, forward bias. So it means in forward bias, there will be a reading of low but not zero. But in reverse bias, there must be no connection from this leg towards this leg. That's why your needle pointer will just stay exactly on the infinity side. It does not move at all. So you have to bear in your mind. Okay? And in that case, the condition of your diode is good. Okay? I hope this is clear. So next. This is our illustration. So possible condition of a diode. As what I said, if the diode is in good condition during forward bias, this is the connection. Okay, do not forget the illustration in here should be positioned this way. The reading should look like this, more or less. Yes, the setting is times 10. In the reverse bias, the reading must be like this. The illustration, the connection of your test proofs towards your diode would be like this. Make sure, of course, to touch this. Okay, make sure to touch the test proof on the leg of your diode. Then this way, if these are the result of your testing during forward bias and reverse bias, then the condition of your diode is good. Yes, your diode is in good condition. You do not need to replace it in your circuit. It is functional. So I hope that is clear. Okay, next one. You have here another possible condition. If forward bias, it will give a reading like this, infinite. Of course, this is the way how you connect your test probe towards the diode to make it a forward bias. In reverse bias, it should be this way, and the reading still is infinite. It means the diode pointer does not move at all. Yes, the same in here in reverse bias. As long as the settings is correct, yes. And if you can get this test result, then the condition is defective, and that is under open. Open, it means your diode now will not allow the current to flow whether it is connected in forward bias or reverse bias. That is why it is now defective and open. Okay, there is no more connection between two legs, and that is, we consider it as open condition. Next, this illustration is our forward bias. For example, there is a reading, yes, the reading of low but not zero, the same, the setting of our multimeter is the same. If it is a forward bias, then you can get a reading of low but not zero, yes, and as well as on the reverse bias, you can still get the reading of low but not zero. Now, in this case, your diode is defective condition and under leaky. So leaky, it means your diode now will allow the current to flow whether in forward direction or in reverse direction. So this time, your diode does not perform its principle that it will only allow the current to flow. This time, the diode now can allow the current to flow either forward bias or reverse bias. So that is one thing that we can have on leaky. Okay, so leaky will give a reading of low but not zero during forward bias, and it can also give a reading of low but not zero during reverse bias. So, okay, I hope that is clear. So again, the condition is defective. The condition defective under leaky. Lastly, the last condition that we have, when you can get a reading of 0 ohm, the 0 ohm in forward bias, as well as 0 ohm on reverse bias, now the condition is defective, and that is categorized as shorted. So it means there's already a direct connection from one leg to the other leg. So your the principle of your diode now is no longer there because it could no longer block the flow of current in reverse direction. Yes, it will always conduct current. It will now act as a conductor. Unlike on the leaky, it will still allow the current to flow, but whether the current is what you want to have there should be positive, it will also allow negative current. So it means it is already leaky. While in the other hand in here, we talk about open, your diode could no longer allow the current to flow. If the condition is good, if the condition is good, your diode will only allow the current to flow in one direction, that's in forward direction. In reverse direction, it will block the current to flow. In forward direction means your diode act as a conductor. In reverse direction, your diode will act as insulator. Okay, so again, recall for our possible condition, we have good. So when the reading is low but not zero, and in the reverse bias, it should be the reading is infinite. It means the needle pointer does not move at all. Okay, that's a good condition. For open condition, during forward and reverse bias, the reading is infinite. So the needle pointer does not move at all, does not deflect at all. And during the leaky, it means there is a reading of low but not zero during forward or reverse bias. And then, lastly, if it is defective under shorted, then your reading that you can get during forward and reverse bias is both zero. Now, as a conclusion, your diode is in good condition when it has different reading from a forward bias and reverse bias. Okay? If it has the same reading on forward and reverse bias, then that is considered already defective. Either shorted. If you try to look at here, the shorted has the same reading, 0 ohm. Another, here in the leaky, you can get the same reading, the forward bias and reverse bias, the same reading, low but not 0. Here in open, you can get the same reading during forward bias and reverse bias, that is infinite. But in good condition, you can have different reading on forward and reverse bias. Okay, that would be all. I hope you learned something out of this discussion. If you have questions as what I said, to have clarification, do not forget to write it on the comment below. Okay, and if you find this video tutorial useful, do not forget to like and subscribe to my YouTube channel. This is Mr. Benirando Sayoridiano signing off. Thank you so much for watching this video. See you soon.